You know that feeling, right? You see this incredible AI prototype from your data science team, and you think, this is a game changer. But then weeks, maybe even months go by, and it's still not a real feature in front of users. So what's the holdup? Today, we're going to pull back the curtain on that whole process. We're going to talk about exactly how AI models make that leap from a cool experiment to a live, rock-solid product. And the key to all of it is something called MLOps. Let's dive in. So, here's how we're going to break it down. First, we'll tackle the biggest hurdle, the whole lab versus the factory problem. Then, I'll give you a quick MLOps dictionary so you can speak the lingo. After that, we'll walk through a real-world 4-act journey of building an AI feature from scratch, and we'll wrap up with a playbook, a cheat sheet you can actually use. All right, let's get right into it. The whole reason MLOps even exists is to solve this fundamental problem, this tale of two totally different worlds. You've got the lab on one side and the factory on the other, and bridging the massive gap between them, well, that's the entire game. I love this quote because it just nails the problem, doesn't it? Think about it. A data scientist can build this incredible, revolutionary engine on a test bench. It's powerful, it's innovative, but it's not a car. On its own, that engine delivers zero value to a customer. MLOps is the entire factory. It's the assembly line, the quality control, the whole shebang you build around that engine to turn it into a reliable car you can actually sell. So let's really spell this out. On one side, you have the lab. This is usually a data science notebook. It's where the magic happens. It's messy, it's creative, it's all about experimentation. But then you've got the factory, production. This is a totally different beast. It demands reliability, scale, and serious risk management. Because in the factory, a mistake isn't just a weird chart, it can cost you real money, and even worse, your users' trust. MLOps is the bridge that lets us move these brilliant, fragile ideas from the lab to the factory without them blowing up. Okay, so if we're going to run this factory, we need to speak the language of the factory floor, right? So let's build ourselves a quick MLOps dictionary. These are the absolute core concepts you've got to know to really get a handle on how these AI products come to life. First on our list, Git and GitHub. Now, for you as a product manager, this is your best friend. Seriously, think of it as the project's official, unchangeable history book. Every single change is logged, who made it, and when. So when something inevitably breaks at 2 a.m., you don't have a mystery on your hands. You have a perfect audit trail to find exactly what happened and why. It's all about accountability. All right, next up is MLflow. We all know data science is about running tons of experiments, and let's be honest, it can get chaotic fast. MLflow is what brings sanity to that chaos. It's like a super organized digital lab notebook. And here's the key for you. It turns model selection from a gut feel, I think this one is better, into a pure data-driven science. You can literally look at a dashboard, sort by the business metric you defined, and say, that one, that's the winner. It's a game changer. Okay, I'm sure you've heard this one a million times. Well, it works on my machine. It's the classic developer get-out-of-jail-free card. Docker is the tool that kills that excuse, forever. Basically, it bundles up the entire application, the code, the AI model, every little library it needs, into a sealed, standardized shipping container. What that means is it will run exactly the same way everywhere. On a laptop, on a test server, in the cloud, everywhere. It just completely de-risks the whole deployment process. So if Docker gives us the standardized shipping container, what's next? Well, you need an automated assembly line, and that is CI/CD. It breaks down into two parts. CI, continuous integration, is your automated quality control. Every time a developer checks a new code, CI runs a whole battery of tests to make sure nothing broke. If everything passes, then CD, continuous deployment, kicks in. That's your automated shipping department. It just grabs the new version and sends it straight to production. The result? You get speed and reliability. Okay. Your container is built and tested. Now you need a place for it to live and work, right? That's where the cloud comes in, services like AWS. To stick with our analogy, you can think of a service like Amazon ECR as the secure warehouse where you store all your ready-to-go containers. And then, a service like Amazon ECS is the factory floor manager. It grabs those containers from the warehouse and puts them to work, making sure they run smoothly and can handle all your user traffic. And last in our dictionary, but absolutely critical, is monitoring. Look, pushing your model live isn't the finish line, not even close. The real world is always changing. And because of that, your model's performance will slowly get worse over time. We call this model drift. So think of monitoring as your post-launch support team, or maybe even better, your insurance policy. It's constantly watching for signs of trouble, so you get an alert the moment performance starts to dip. That way, you can fix it before it becomes a silent killer for your product. All right, that's enough definitions. Theory is great, but let's see how this all works in the real world. We're going to put all these pieces together and walk through an actual project, building an AI system that predicts if a customer is going to default on a loan. And we're going to do it as a 4-act journey. Now, before anyone writes a single line of code, this is where you, the product manager, come in. Your first and most important job is to define what good actually looks like. For our loan predictor, think about the business risk. If we miss someone who's going to default, a false negative, that's a huge financial loss. Catastrophic, really. But if we accidentally flag a good customer for review, a false positive, that's just an inconvenience. So the stakes are not equal. That's why we picked a technical metric, the F-score, that directly aligns with our business goal. Find as many of the real defaulters as we possibly can. So here's the roadmap for our little play. Act 1, the proving ground, where we get our hands dirty locally. Act 2, the shipping container, where we package it all up. Act 3, the assembly line, where we hit the big red automate button. And finally, Act 4, the watchtower, where we keep an eye on our creation out in the wild. Okay, Act 1, the proving ground. This is all about building a solid foundation before we even think about the cloud. It means starting with discipline, a proper code repository, a clean data pipeline. And we have to be super careful to avoid a really sneaky trap called data leakage. This is basically when your model accidentally gets to peek at the answers during training. It makes the model look like a genius in the lab, but then it completely falls on its face when it sees real-world data for the first time. And here it is. This is that ML flow dashboard we talked about. This is where the magic of data-driven decisions happens. We basically ran a bake-off with a bunch of different models to see which one performed best. And as the PM, I don't have to rely on anyone's opinion. I can just come to the screen, click on the column for our key metric, that F1 score, and boom, the winner is right there at the top. It's totally objective, no guesswork involved. All right, on to Act 2, the shipping container. Now that we have our champion model, we wrap a simple web application around it. And then, to make sure it's ready for the big leagues, we use Docker to package the whole thing up, the app, the model, everything, into that sealed, reliable shipping container. At this point, we have a single portable asset that's officially ready for production. And now, for my favorite part, the magic of automation in Act 3. This is where we build out that CI/CD assembly line. And get this, once it's set up, all a developer has to do is type one simple command, git push. That's it. That one action kicks off a completely automated chain reaction that tests the code, builds our container, and pushes the new version live to the cloud. The whole thing happens in minutes with zero manual intervention. And here's what that assembly line actually looks like. This is a screenshot from GitHub Actions. You can see it's a 2-step process. The first job, build and push, does all the quality control and packages our container. As soon as that passes with a green checkmark, the second job, deploy, automatically kicks off and sends our application to AWS. It's just a beautiful example of speed and reliability working together. And we've arrived. This is the final destination. You're looking at our factory floor, the AWS dashboard. That little green running status means our container is now a live task, managed by Amazon's cloud. It's no longer an experiment. It's officially out there, serving predictions to the world. So what was it all for? This is the payoff. We went all the way from a messy experimental notebook to a clean, simple, live web app. A real user can now come here, punch in some numbers, hit assess risk, and get a real-time prediction from that model we trained, all running reliably in the background. That is the full journey, end to end. But wait, we're not done yet. We've reached our fourth and final act, the watchtower. And this is so important. Deployment is the starting line, not the finish line. Now we have to monitor our model for those silent killers we talked about. Things like data drift is the data from new users starting to look different from our training data, or concept drift, maybe a recession hits and the very idea of what causes a default changes. Monitoring is how we protect our investment and make sure our feature continues to deliver value. So there you have it. We've gone from a completely blank folder all the way to a live, running, and monitored AI application. Now, let's boil all of that down into a simple, actionable playbook, a cheat sheet you can take with you to your very next AI project meeting. Okay, here's your cheat sheet. 5 key rules. 1. Think in pipelines, not just models. Remember, the factory is way more valuable than any single engine it produces. 2. Containerization is non-negotiable. It just solves too many problems to ignore. 3. Instrument everything. If you can't measure it, you can't manage it. That goes for the lab and production. 4. Security isn't an afterthought. Build it in from day one. And number 5, say it with me. Deployment is the starting line, not the finish line.
We started this whole explainer with a simple question. Why does it take so long to turn a cool AI experiment into a real feature? And hopefully, now you see why. It's about building a factory, not just an engine. So I'll leave you with this question. The next time you launch an AI feature, and everyone is celebrating, take a moment and ask yourself, is this the finish line, or is this just the starting line? Is this where the real work begins?